Hello, everybody. My name is Chad Jennings, and I'm the head of customer voice and product experience here at IBM Software. And welcome back to another episode of Technical Client Stories with IBM. In these stories, we unpack a use case, we go through the solution, the architecture, a couple lessons learned, and where this thing might go next. And the goal of these is to provide the community with some how-to recipes on some of the elements within IBM's tech stack. And so today, we're very fortunate to have Rick Atkinson, CTO for Baypoint Advisors. So welcome, Rick. Thank you for joining us.
Hey, thanks for having me, Chad. As Chad said, my name is Rick Atkinson. I'm the CTO of Baypoint Advisors. We're an investment management company in the Atlanta area. We focus on private market opportunities that are typically overlooked by the traditional investors. And one thing we've done here at Baypoint is we've built our own investment platform called Atlas that is geared towards providing our clients with a superior customer experience.
All right, let's jump straight into the use case that we're going to discuss and what is the pain point that we're solving. So Rick, can you lead us through?
Yeah, so a key part of the discovery process in investment management typically is a concept known as secure data rooms. And these data rooms in the financial space are really just like a file repository of documents, typically, that are there for a certain opportunity. And typically it's hundreds of documents. It's a lot of documents. These rooms are built, ironically, for people who don't have a lot of time, but need to explore this opportunity. As a result, it's inefficient. It's something that's ripe for disruption because there's just so many files and such little time to go through them.
It's a perfect case, an early case for AI because like Gen AI models generally do synthesis and summarization pretty well. And what's interesting here is like your goal wasn't to do an AI project, it was to solve a pain point for your customers.
Yeah, we didn't want to do AI for the sake of AI, right? Everybody, that's the buzzword and everybody wants to do something in AI, but I wanted AI to solve a business problem for us here. And one of the things I found interesting is as you're working with LLMs is, being able to bring your private data into these LLMs and use this concept of RAG AI to bridge structured data, which, like SQL databases, whatever, and unstructured like PDFs and documents. And again, these rooms are monolithic with all this data. And what if you could bring a chatbot into it and you could ask questions to the room directly?
When you talk about structured and unstructured data together, like it's one of the the holy grails of data analytics. Next we'll be talking about like transactional data processing as well as analytical, but like that'll be for a different episode. So this one's a traditional RAG application, so retrieval augmented generation. Rick, just in case there's some folks out there that don't know what RAG is, can you spin us through? And if you do know what RAG is, you can skip ahead about 32 seconds. I timed Rick's explanation.
Yeah, well, basically RAG is just, it pairs an LLM with your private external data store. So it helps in that your answers are grounded in your own data, not data that the LLM is publicly trained on. And it's actually a very appropriate acronym. RAG is retrieval, as you said, retrieval augmented generation. At query time, it's going to retrieve relevant chunks of data from the documents, and it takes this data and basically augments or appends this to your prompt. And so when it sends it to the LLM to process it, it'll answer the prompt along with the corresponding evidence or documentation. And then it will then provide a response with citations, backing up, where the answers came from. So, it leads to better answers in the end. They're source-backed answers from your data. And it's a way to do it in a way to not make your data public to the LLMs. It's just used in conjunction to help answer the question.
Yeah, that's an important point, right? When you do a RAG app, you're adding an embedding into the LLM as opposed to, changing the model of the LLM itself. So, when you do that, like your customers will get the benefit of the added data, but like that's isolated to your use case. Like somebody else, like if I was doing it over here for a different company, we wouldn't have any cross contamination. So very secure.
Yeah, and that's key in the fintech space. We cannot build this stuff and then hand it to competitors or whoever to have access to that information. So that's where, to me, RAG is just very critical to businesses.
Yeah, as well as the security, the capability and the security. So
Absolutely.
now that we've done our primer, I think we were in at about 62 seconds on 32, so that's all right.
Sorry.
Let's let's go through and look at the components of your architecture. So go ahead and toss it up on the screen, and let's go ahead and walk through the chat process diagram.
Okay, so yeah, this is covering the chat process, but just to kind of start before I go into this is, and actually, as we go through the process, we'll talk through some of the tooling decisions that we made in this. So
Perfect. Yeah, let's do it as we go.
so let's just start with the customer. They've got a question, about one of the documents in the data room. So they ask their question, and that is sent to our platform, the Atlas platform I mentioned. And one of the things that's nice here is that we have control over the question and the prompt, and so before we're going to send this off to LLM land, first we've authenticated the customer, and we've also collected some additional context and history on the customer, maybe some of their prior questions they've asked, context being maybe what access they have. What documents does this person have access to, or what relevant information are they privy to see? So we collect that on the user of the question, and then we'll take their question and all this context. Now we're basically after, let's get the embeddings we need to augment our prompt here, right? So this is where IBM DataStax comes in, and we make a call to our IBM DataStax data API. Now, one thing I'll add to this here is that, when we started looking for a vector database, AI tools to work with here to solve this business problem, our stack is effectively, we're using Angular as a front end and .NET Core as a back end.
Okay.
And one thing you'll see in a lot of the AI tooling is a lot of it's Python based and different things like that. And one of the many things that was appealing about Astra was that there was a REST-based data API to call, which is basically language neutral. You can write in whatever language you want, and also they provide a .NET Core library we could SDK that we could hook into directly as well. So that kind of solidified the selection here of IBM DataStax for that part. So basically we pass our question and context into the data API, and then what it does is it takes the question and begins vectorizing and filtering the question down. And by that I mean our data, and we'll get to this when we talk about the embedding process, but there's certain metadata that's cataloged to all this data. And so we need to filter the question down to the right room, to maybe the right document. We also need to filter down based on the access level of the user. If this user doesn't have access to all the documents, we need to make sure the answer is only based off what they are allowed to know.
Mm-hmm.
So that's then passed into, so the data API then leverages the Azure OpenAI embedding model here to then query the Astra database to basically come back with the most relevant embeddings. So, and we have full control over that through our parameters. We can say, okay, well, I want you to only get the top 10 embeddings to use here. I could open it up and say, no, let's get 50, but you're always weighing performance with accuracy here. They want an answer where they're not going to wait 5 minutes for the answer. So we want to dial it in, make it performant, but make it as accurate as possible. So through this process, this will get returned to the Atlas platform with basically, a list of embeddings and a citation on where it came from. And so the final step here, or the final couple steps here, we now take that information, we pass it to a different LLM model. We're going to pass it to a chat model here. And like I said, we're using Azure OpenAI here. And the reason is from a security compliance standpoint, Azure OpenAI is not publicly available. None of your data within that is used to train, the public LLM. So it was a smart choice for us to use Azure OpenAI, I thought, in this case. So we pass all that information, the prompt, the instructions from the room, historical context from the user, along with the embeddings we got back from Astra, and that basically returns an answer with citations back to the end user. So it seems complicated, feels like, walking through that took a while, but this literally happens in milliseconds as you traverse across the steps.
And what's interesting about it is like you're using like a couple different databases, a vector DB as well as and then two different models. And what's interesting about by separating those two different models, right? You've got the embedding model, which goes ahead and reads the chunks and then figures, with the vector database, figures out which chunks are semantically closest to the answers that you want. And then if I read it right, all of that gets passed back into the chat model, which composes that into stuff that a human could read.
Correct. And, part of the learning experience for me as I got started with this is, trying to determine the right, model to use for the right job. So like the embedding model you use, LLM model, is very different than the chat model that you'll use. And, that's part of the discovery process in this, is figuring the right one to plug in where.
Well, perfect segue. Let's dive into the embedding model.
Okay. So yeah, let's start, kind of similar here. We'll start at the beginning here. And what I call a steward here is basically a, maybe an admin user of our system. And maybe it's the room creator, the person who's loading the documents into the room. So the steward will upload the documents into the room. And, so first thing that happens in the platform, it's going to go move it into storage. And, in this case, we're putting it into a blob container within Azure. The documents are then logged to the database, so that our SQL database is now aware that these documents exist and they have pointers to them. And then the final step here is to, basically catalog these documents and chunk them in for vector storage. And that's, again, where IBM DataStax, the data API, comes in. And we then start, parsing these documents into, digestible chunks for the AI. And we just, what I love about this is that the data API is a black box for us. I don't need to understand how to work with vector arrays and build and compute all that on my own. Instead, I just give it, the chunks of text that I want it to do, and I tell it to vectorize it, and then it goes through the process in this black box here of doing that. It vectorizes the chunks and leverages the embedding model to then insert the vectors into the collection, which is housed within Astra. And like I said, that's the beautiful piece to me, is that I don't have to figure that. Yeah, it's the magic part for me. I don't have to figure that out. I just give it what I need chunked, and I'm also giving it the metadata with those chunks. Like, hey, here's 700 characters from this document, and it's related to a document called this that's in this room and has an access level of this. So now each chunk is inserted individually into the database collection, ready for query, retrieval later.
Yep, that makes perfect sense. And how, if you add another, how do you maintain this model, right? Because if the steward's a Baypoint Advisors employee or operator. And so if that steward's I got another document that's relevant to the investment on 38th and Pine, I don't know, let's say it's an apartment building or something like that. Yeah. And you put it in, do you have to rerun the entire process again, or can you how do you handle updates?
Well, it's done on a per document basis. So if you just add a new document, it will now, run through that process again, drop it into blob storage, put it in the database, and vectorize it. If we're replacing a document, maybe we have an updated document that we need to put in there, in that case, we would go through, and via the API, we would delete out the vectorized data from the prior document, and we would basically just reinsert the new chunks in to replace that.
Okay, so the grain of your operation here is a document, and so if you put in a new document, you don't have to run the whole thing on the whole globe anymore.
No, I mean, it's all automated, so they can upload the documents one at a time, and each one will go through this process. That typically what happens is they'll load, say 300 documents to start it, and then they'll add another two or three, and as each one to them, to the end user or the steward here, they just upload the document, and they don't know what's happening behind the scenes, but each document is running through this process we see here.
What was the biggest surprise? Like, and talking about good surprise.
Yeah.
What was the biggest surprise here?
Honestly, I was just surprised at just how good the answers were out of the box. We hadn't even begun tweaking the model, or there's certain parameters within RAG you can tweak, like the temperature, number of tokens, et cetera, a number of citations you want back from the retrieval process, and they were just really good out of the box. And the answers were very clear and well reasoned. I kind of expected the answers to be like a cut and paste from, a paragraph within a PDF document, like, oh, that's from page 78, and it just repeated it verbatim. No, it's like it read the entire thing, understood it, and then gave a well-reasoned response based off its understanding of the document. Now, sometimes you have...
That's just perfect.
Yeah, I mean, sometimes you have very quantitative answers like, hey, the answer should be 15. Okay, and yes, the answer is 15 because it found the right answer. But sometimes it's more of, hey, what's the overall strategy here of what you're trying to do? And that's not going to be a cut and paste from a paragraph. That's going to be, how well does it understand? And it's crazy to me because it's taking various embeddings, and again, that's where Astra really shines. It's pulling back the most relevant embeddings it's making the chat model look really good because it right. Feeds it really good information to make a well-reasoned answer, and it will lower hallucinations because you don't have some LLM going, let me just kind of wing it on the answer here. No, it's given really good answers. And by the way, by us controlling the prompt, we can be very explicit to the model to say, oh, and by the way, you're going to base all your answers off of these embeddings you're getting. You're not going to stray from that. You're not going to go, try to figure it out if you don't have the information. You're just going to tell me I can't answer the question if you don't know it.
Tell me about the other side of the coin. Like, were there any unexpected hurdles that you came across, and what you need to do to overcome it?
I mean, the devil's in the details with this stuff. There was a lot of configuration to set up here. Because when you're working with, we've got our own platform and API we're working with here. And now we're working with the Astra Data API. We're also working with two different, LLM models, an embedding model, a chat model, both being provided by Azure OpenAI. So you gotta dial these things. They all have to be communicating the right way to each other. So that just takes some planning and iteration. But honestly, that's where the IBM DataStax team really shined here for me. They when I struggled with some of this, the team would step in and help with this and kind of get me back on the right path here.
Let's tap into that one a little bit. So how did the DataStax team go ahead and lean in and help?
One thing about this whole process is that, especially when you're doing something new like this, it can feel kind of lonely, like you're on an island, like maybe I can't do this. Maybe it's too cutting edge or too bleeding edge. And when I started this path, first of all, we went through this process of trying to select a vendor, and won't name any names, but I was experimenting with a few other vendors, and I would hit roadblocks, and I'd ask a question through their support or whatever, and I'd get nothing, silence, crickets. So came across the IBM DataStax and Astra and spun that up, and immediately the team there was like, hey, jumped in, what can we do to help here? We've opened up a Slack channel. We had weekly meetings. I would kind of go through what we're trying to do. So kind of explained what we were trying to do. And they, we started with like a proof of concept that we were trying to build out. And, they came in with Langflow, just started to show me from beginning to end, hey, here's some documents, let's load them in.
User, like
yeah. So just to prove out that, hey, this does work, before we got deep into, a coding, and trying to tie it into our platform. And they were just really helpful. They would jump on a call with me, and I'd be stuck on something, and they would get me unstuck. And I honestly don't believe we would have ever completed this project if I had not had the help of that team there to pull this off.
I'll tell you what, we're gonna make sure we send that note to the team, their managers, and their moms, because they'll be everybody's gonna be real proud.
Yes.
And I'm really glad they came through for you like that too. That's great to hear, right? Because it's not all about tech, right? It's also about people.
That's right.
But speaking about tech, where do you see the next technical evolution of Atlas going?
Agentic's the big thing right now, agentic
Naturally,
AI, and
yeah.
it's great to do all these things, and the chatbot stuff is great. However, I think the real power comes when you unleash these things and you have these agents working 24/7. You're looking at your private data, but then looking outside maybe to public, data, third-party data, market data, whatever, and trying to help make decisions for your business there. That is to me, the real payoff. And that's where, I really see the next frontier for us.
Yeah, we see that the trend, like, systems of, intelligence systems then taking action on your behalf. So, the chatbot experience is really like a 2024 2025 thing, then agents, and then systems of agents. So like there's definitely a progression here with just ever increasing capability. So
yeah, but it's good to go through the learning process of, like, the learning how the RAG AI process works, and figuring out that this is just another tool, to use in your journey of walking the AI road. I think and I think, like I said, I think the DataStax Astra, team and technology was a big help in getting us to where we are today with it.
And we're going to have that be the final word on the matter. Rick Atkinson, thank you very much for joining us in this episode. My name is Chad Jennings. Everyone, thanks. Take care.